let's dive in.
Thanks, Chacha. Well, hello, everybody. My name is Madison Zulowitz. I am the event coordinator here at Doug. So I'm here to just give a quick introduction about who Doug is and what all we offer and help answer any questions you may have. And then, like Chacha said, I'll pass it over to our speakers for today. So a little bit about Doug. Doug is a free community for users, implementers, and resellers of Microsoft business applications. We mainly support Microsoft Dynamics 365, GP, and Power Platform, and we hope to give people the tools to help them in their professional careers and kind of grow and excel. Our rules of engagement are we essentially ask that these meetups are held to be solely educational. So please no sales pitches. We ask that everybody in the chat engage with our speakers and ask lots of questions. I'm sure that they will mention that as well, but we want these to be engaging and for you to learn as much as you possibly can in these. So very excited to have our speakers here today. Doug or Dynamics user group, we have multiple different programs. So we have open online discussion forums, we have webinars, we have conferences, local meetups like this one. We also have a YouTube channel where all of our recorded virtual sessions are posted. So if you're ever curious about what other meetups are doing around the world, we have lots of great topics posted on our YouTube channel, and all of this is free to check out. So we have our 2025 Doug regional meetups. These are a little bit larger in scope than our local meetups like this one. So they are full day events and in person. We usually have multiple different breakout rooms talking about multiple different products. We include breakfast, lunch, usually a social hour. So lots of great networking and educational opportunities. And we're going to Philadelphia on March 12th. We're going to Canada, June 16th and 17th, West Africa, July 19th, and I'm sure Chacha could talk a lot about this, but we're going to Kenya, July 24th and 25th. So if you were in the area, we would highly suggest that you come. It is really a great day of education and networking. We also are going to Denver, Colorado in August, Ohio in August, Europe in September, Texas in September, and Tampa again in January of 2026. So if you're able to make any of these, we would really encourage you to try and come. And we also have our largest conference of the year, DynamicsCon, coming up May 13th and 16th of 2025. And we actually have a promo going on to all of our meetup members. You have to register before February 28th. So if you are interested to coming at all to DynamicsCon, I would highly suggest doing this before February 28th so you can get that free ticket. This is a multi-day event, lots of education sessions, lots of networking, and we actually just posted our agenda on the website as well. So if you're curious to see what content is going to be there, feel free to check that out on our agenda. And I'll send this I'll send this code in the chat if anybody is interested in coming, as well as some more information about Doug. So if you have any questions, feel free to reach out to me and I'd be happy to answer. But other than that, I'll pass it back over to Chacha to introduce our speakers for today.
Great. Thank you so much, Madison, for that great introduction. Basically, that's who we are, Dynamic User Group Kenya. We welcome all of you for today's event. We'll have our presenters do the presentations. We'll have a later session for Q&A. But if you have a pressing question, you can please send it to the chat. So I take this moment to welcome Stefano, Demiliani, and Leo Tukani. I hope I've got pronounced the name right. They're both Microsoft MVPs. They'll start by giving further introductions about themselves and direct dive into the presentations. Yeah. Thank you. Welcome.
Thanks a lot. Welcome everybody here. My name is Stefano Demiliani. I'm from Italy. I'm a Business Central MVP and an Azure MVP. I'm working mainly in the Business Central development and serverless development in my company in Italy. Together with me, Duilio.
My name is Giulio Tacconi. I'm MVP MCT, and then I'm working for EOS Solutions as performance specialist, and this is it.
Okay, the topic for today is a topic that we started running last year in across Europe, and we think it was interesting to share not over the confine of Europe. So we want to talk about large customers and tips and tricks for handling really big large customers in Business Central Online. So the topic for today is first of all, what is the definition of large customer? We want to be clear on that. We want also to explain the large customer challenge that we have when running this type of customer on the cloud. So mainly talking about transactions, concurrency problem, database growth, integrations. We also want to explain the applied solution that we have really in real world apply to these type of customers. And we also want to talk about best practices for developers in order to turn up your code for handling a large customer. Then at the end, we plan to have a moment for answering questions that you can feel free to write directly in the chat. So first of all,
the large customer. Yep, exactly, Stefano. So the first things that you might ask it is what it is defining a large customers. So the first things that you have in mind, it is the size, the database size. But a database size per se, it can only be a matter of the capacity that you have. You might have all the people that are accessing read-only this database, and then those are just static data, and it doesn't make any kind of trouble, most probably. So the database size per se does not define a large customer. The second one, it is the number of users. So most probably you were asking here and there people, how many users you have it in SaaS, but you can have one users that it is running constantly a posting or running a report that could completely destroy your performance. Or you might have 1,000 users that merely staring at one of the pages. So the number of users, it is just a raw-based estimation in the mind of everyone of the number of transactions. So the best way to define a large customer, it is its transaction volume and the type of transactions, because this one will shape the lock-in scenario, and together with the concurrency that you have. Right now, it is not the number of users, but how many users you have it in per time. Let's say that maybe you might have 100 users, but those one are split in two rota of 50. The concurrency will be 50 and 50. It will not be 100. That is what concurrency means. How many users at the same time are doing stuff in Business Central. And the transaction that they are doing, because they can only be connected one time, but they might have some background session, child session, they spawn up other stuff. So the number of sessions might be different. So what it is a large customer? A large customer, it is one with high transaction volume and type, high concurrency, that is better than the number of users, as we have seen, it is more accurate. And high database growth, it is better than the database dimension because it is a dynamic data, and then you know how much your table will grow in size. Then you have to take measure in order to tackle problems that may arise from this one. Then they might have high complexities, like the number and type of SVRs that you have it, API, large source apps, and last but not least, the special requirements, because it might be a 24/7. So maybe the update windows has to be kept as low as possible, but you have to fight with the operational limit and the constraints that the BC online version imposed to you. So I want to give you one example with one real customer. So if you look at this one, this is a real customer with this number of environment. As you can see, it has a multiple number of production. In these cases, there are 2 production, and there are a number of sandboxes. You might say that this one, it is already over the capacity because it is more than 100 gigabytes each environment. Well, I have to say this is not, because this one, it is the user license, it is more than 1,500 and so on. So the capacity is still inside this one. So can this be defined a large customer? From the size and the user, it could be someone give problem, but it does not give problem, because this one do have 47 companies, more or less, for each of the two production environments. And if you do the math, it is like having more or less 10 users each, and really you have 470, 500 BC user, and then they're using just financial. For us, this one has never been a problem in matter of performance. And then we are handling this customer quite well without any kind of problem. The only problem, it might be on the job queue in synchronizing the data between the data within this company. But it has always been a very good customer, and we have been always a very good partner related to this one. Let's tackle the first one, the high concurrency. Now, the high concurrency, let's have a look at this other live customer, of course. This one actually, it is 500 users in the licenses, and the total sizing, it is 159 of 607. But let's see how it is, just to give you the size of the dimension of the database.
1 second. Oh.
Yes, dimension of the database, well, it is 100 gigabyte. And this one really is a problem compared to the other one that was double in dimension because of the concurrency. Those are buckets taken by hour. And as you can see, those are 100 users per hour concurrent at the same time. Plus, as you can see from the next graph, there is the invisible pane of the API. Those are just taken every minute. There might be between 100 to up to 300 with spike on 400 calls per minute. So this is really an environment where the concurrency counts. So how you handle this large, with high concurrency with large customer? The first suggestion is you have to implement a solid telemetry practice in order to dissect and analyze what it is your traffic of users and transactions, the type of transaction that you have behind the scenes. The main signals that you have are the long-running SQL queries, and if there are or not, better if you haven't, log timeout, and it's log timeout snapshot, and if there are this deadlock. Those four signals are very important in order to analyze how it is in a time frame your concurrency inside. Then you decide the measure that you have to take in order to, for example, decouple, use much more background session, more job queues, or change the way you're designing your object in order to reduce the concurrency. And there is one hint in this one. If you have not already done, because this one is there since version 23, and version 24, you have to opt in. But if you're already in version 25, this one, it is enabled by default, and there is only a way to go back to this one, but keep it enabled, because the three-state locking, it is very good in shaping a different way how you do the concurrency, because it is changing the way the isolation level is set up automatically. Every implicit blocking, insert, update, delete that it is taken.
Exactly. Three-state locking is mandatory to enable if you have not yet enabled in all the environments.
Yeah, that's true.
Another important aspect about large customers when dealing with large customers is related to posting. So in Business Central, I think you know that posting is one of the main performance problems in general. So if you analyze the posting routine, you will discover that the posting routine has several set of steps. In a general posting routine, usually there are a first set of steps where Business Central locks the current document and does some calculations related to discounts, VAT amount, and something like that, retrieve the number, series, and so on. And then there's a second step where Business Central starts writing and posting each line of the document. And this second step is the real part where that takes time, because if you analyze carefully a single posting steps, you will discover that 90% of the time is spent on writing records on the ledger table, so customer ledger entry, item ledger entry, resource ledger entry, and so on. And here is where GL entry is usually locked as a semaphore for that. So in order to handle large customer, if you have very, very large posting documents, for example, with tons of lines, something like that, and a really big amount of documents to post, this can be a problem with large customers. So how to handle that?
So the things that we did, it is just, you just have to take measures. So we decided to take exactly this kind of posting, that is salespost.run within a sales header, and we decided to apply this using the tools that Microsoft provided to us, that is the BCPT, Business Central Performance Toolkit. And analyzing this one in creating session over session over session, we realized that easily, if you have AI concurrency, then you will receive a lock timeout in 10, 20 sessions. Meanwhile, they are posting within the concurrency. And you will receive this kind of error that you can see. We can save your change right now because a record in table GR entry has been updated and so on and so forth. Meanwhile, we were doing this kind of experiment. We found out that it was slowing down the posting, invoices after invoice, posting after posting. And then we have looked at how the standard it was set up. And we discovered one thing, right, Stefano?
Exactly. First of all, what we discover is that Business Central as standard has in the inventory setup two wonderful options that permits you to do automatic cost posting on the item ledger entry tables and automatic cost adjusting. As standard, Business Central set these two flags with automatic cost posting true and automatic cost adjusting always. We suggest to never do that because it creates a lot of lockings and your performance problems will decrease a lot. So our suggestion when handling a large customer is to always set automatic cost posting to false and automatic cost adjusting to never. And then if we need cost adjust costing, is absolutely better to schedule the adjust cost item entries report with job queues and run that, for example, during the evening or night or something like that. But never do automatic cost posting in real time because it is prone to locking. So it's in our recommendation is that is bad. So absolutely better to handle this with large customers. But remember that this is the default. So this is something that you need to change when setting up a company for a large customer.
Right. Then what we did actually, in order to kill the concurrency, of course, we turned off this evil flag in the way that Stefano showed up. And this is, of course, in our company, a main practice. So I believe that none of our customer, it is running at the adjust cost during posting, but everyone, it is scheduling the report. And then what it is the solution for the high concurrency? It is, of course, to kill the concurrency. And how you kill the concurrency? You serialize. So everything that it is parallel, you put in a job queue. So what we did, we took the BCPT and we spent a few days in order to analyze how the sales post via job queue, .enq sales document that is in the standard was working. So the things that you can see actually are the job queue entries. And as you can see, there is this waiting state that it is a new status that popping up and started since version 24. And we have taken some measure over this posting in order to see how far we can go in a standard way when we are doing posting of this sales document. And we have just quite some results during our experiment. So take this as just an example, a scholastic example. And those are taken using, of course, BCPT in online sandboxes. And the experiment was actually to create randomly different sales header with between 1 and 5 sales line, between 1 to 10 sales line, 1 to 20 sales line, 1 to 13, and 1 to 100. And as you can see, the number of sales order posted per hour was spanning from 3,000 to 400, depending on the number of sales line that you have it, of course. And the things that we would like to show it is that if the number of hours, if you want to post 10,000 sales orders, for example, if you have on average 5 lines, it is 5 hours. But if you have quite a discrete number of lines between 1 to 100, on average between 50 or 60 lines, then this might take even 1 day, 24 consecutive hours in order to post all of them in a serialized way. Just for inference, with the statistic that we made, if you want to know how many days are needed to post 1 million of sales order that have on average between 50 to 60 lines, these are taking 100 days, half, 1/3 of a year. But this was just an inference.
Just for information, this data are coming from online sandboxes, so probably can be something can be better, but this is just to prove that this is an order of duration.
Yeah, and the way that you can measure it.
Exactly. Another problem with large customer is that we have with handling large customer is related to statistical fields. I think that you know that Business Central is quite easy to create a statistical field by creating flow fields. And flow fields are easy to be created, but also are prone to locks and to cause slow page loads. So if you abuse on flow fields on a page, the first type of experience that you have is that when you open the page is slow to open. So in our recommendation is when possible, please avoid using flow fields. But instead, if you have statistical fields on pages and something like that, use the combination of page background task and read isolations. What does that mean? It means that if, for example, you need to display, like in this example, in the customer card, you want to display the sales amount of that customer, sometimes it's better to avoid to create a flow field on the customer table, but instead it's better to create a field called sales amount here, and then use the page background task to calculate that field. Page background task is a feature that permits you to, from the main page, in this case the customer card, passing a parameter with these methods and each dictionary, name of the parameter and value of the parameter, to a background task that is a code unit by using curepage.enqueue background task methods. In the code unit, you can do your real calculation. So you can retrieve the parameters from the caller page. So with the page, you got .get background parameters methods, and then you can perform the calculations. The calculation here is important. You should do that with best practices for lockings. Best practice for locking means that first of all, you need to load only the fields that you want. So for example, here I need the line amount of the sales line, so I use set load fields, not the entire sales line. And then using the read isolation. Read isolation is a new way that you have now. You will explain that later also, that permits you to do access without locking. So you can specify the transaction isolation level of your SQL queries, and then you can read without doing locking. So this piece of code, for example, is absolutely better and much more performant than using flow fields on sales lines, because here also the page is not waiting to the calculation on the fields, but you can open the page and directly close if you are not interested to see the value of that field. And remember also that in the next release, Business Central release, in the current release, all flow fields that you have in a table are calculated when you open the page. So this is the reason why you have, if you have a lot of flow fields in a page, in a table, the corresponding page is loaded to be loaded. But in the next release, Business Central release, probably Business Central 26, this will change. So only displayed flow fields will be calculated. And as a general best practice, please don't abuse on flow fields. Also include in role centers, because this can create a slow experience for your users. Another best practice is related to number series. I think that you know that when you have documents in Business Central have number series, can have number series, and there are documents in Business Central that can must have sequential number series, like the invoice, for example. But there are a lot of other documents that doesn't need to be sequential in terms of number series. Business Central has now, from some releases, a set of methods that permits you to detach number series in a no-locking way. But also Business Central has something like, probably not so well known, way to handle number series by using number sequence. And number sequence is an IL object handling metadata that permits you to create and manage number sequence in code. So it's built on using SQL Server sequences, and it's not associated on any table. So it's not like number series where you need to go into a table and do something. Here it's metadata driven, and with number sequence, in code, you can directly set up a number series, obtain a number sequence, and update your number sequence without going into a table. And this is absolutely faster than using standard number series. Obviously, the only problem is that if you have this is only available, useful if you omit gaps. Otherwise, number series is if you don't omit gaps, number series is the way to go. But just to prove that, here we have done an experiment where we try to reserve 10,000 of number series in the transactions. First of all, by using the new number series batch code unit, that is a no-locking code unit available in Business Central in the latest release, that permits you to obtain number series for a set of transactions. And you can see, like in this example here, to retrieve 10,000 number series from the number series table by using this code unit, it takes about 2 seconds. But if you do that the same by using number sequence, so metadata driven in code, you obtain reserve 10,000 number series for a transaction in the order of milliseconds. So it's absolutely faster and faster. Only problem, as said before, if you have errors in the transactions, you will have gaps. So this is available and useful only if you admit gaps in your transaction. But in many transactions in Business Central, gaps are absolutely valid.
Correct. And related to the number sequence, Microsoft recognized the effectiveness of using this one instead of the traditional number series that does not admit gap, but they are quite a lot of locking. Let's consider, for example, when you do warehouse posting. So let's say that I just want this 3 or 4 or 5 writes that I want to do in the warehouse entries. If I just, in the traditional way, I just want to also post this other one, then I have to wait my time when this transaction it is over, and then I can post it. And then the next one goes, and then the next one goes. With version 2024 Wave 2, that it is version 25, as you can see from the insert record, there is this get next sequential number. Right now, I can be in concurrency, and then this means that I can be much more faster in inserting my warehouse entries. This one, it is an opt-in in the feature management, and of course, we are enabling this anywhere. Because of in the warehouse entry, it is not needed. It is not a financial table. It is not needed that you have number 1, 2, 3. You can have 3, 25, 50. So it can admit this kind of gaps within the numbers. One thing that you have to keep an eye of it it is that also the SIFT, the indexed views, this one has been just slightly changed by the addition of one field that is called SIFT bucket number in order to avoid deadlocks. So if you have some PTs in there, then you just have to, those PTs are adding this SIFT, you just have also to add as last field the SIFT bucket number in order to avoid, let's say, to have much more concurrency than it was in the past and respect the same philosophy that has been introduced. But what will come next? Maybe in the next version, Microsoft will open also to item ledger entry, to value entry, to have this more concurrent mode. This means that your large customer might have even better performance.
Exactly. So next topic, we talk about iDatabase Grow. Related to iDatabase Grow is obviously another problem that you have with handling with large customer. What about iDatabase Grow is mainly related to cost. Obviously, the first aspect that you need to handle. If your database is growing a lot in size, you need to probably go over the standard capacity that you have in your tenant, and then you need to pay more. To handle iDatabase Grow, the first tip that we want to leave to you is that you should enable retention policies at the beginning of the project. So enabling retention policies is important, and it is important also to do that in the analysis phase of in your project. Is a step that you should have in your to-do list when you set up a new company. So determine the table that must be deleted periodically and the policy to delete these tables periodically. If not enabled at the beginning, can be a problem, because if you discover that you have extremely large tables after the go live, maybe after 1 year, 2 years, I don't know, and enabling retention policies in existing large tables can be a problem on deleting. Sometimes the steps on deleting takes too much and it fails. So recommendation is that if you don't enable a retention policy at the beginning, but you want to enable retention policy because you discover that the table is very big, delete the table with custom cleanup or archive the data with custom cleanup, and then activate retention policy on that table. Remember also that retention policies permits you to have a standard set of tables that can be under retention policies. But if you want to apply retention policy to your custom table, you need to register that on the retention policy feature. So to do that is simply in your on install app per company trigger of your app, you need to call this unit retention policy allowed tables and register your tables. Then when registered, your tables can be discovered from the retention policy user interface, and then you can apply the retention policy you want to that records.
Yeah, and remember the practice that I told you initially. You just have to implement the telemetry in your company, because one of the signals of the telemetry is if you have enabled the retention policy, and every time it is running, it will tell you what it is the table and if there have been some records that has been deleted. So you can keep track of the things and the job that it is done by the retention policy behind the scene. And as you can see, everyone has been caught by this one, changelog entry, voila. This is a real life example where at certain points, looking at the table information, we just have 37 million of records in the changelog entry. That means that 10 gigabyte, and this is the online. At that time, this database was more or less 40 gigabyte. This means 25% of the database was a changelog entry. So when we did this, as mentioned by Stefano, we cannot enable the retention policy and pretend that this one will kill 10,000 for each run of the record. So we have to do our practice and manually delete this one using a special code unit in order to clean this up. And then we put everything under retention policy. And as you can see in this graph, in this table behind the scene, this is how the telemetry it is catching up on even custom tables. Okay, one important things in this one, in your practice, you just have also to calculate the growth rate. So take a snapshot of the capacity in the tenant admin center of how it is the dimension of your databases, then after 1 week, and then or after 2 weeks, and then add an inference and then take a graph in order to see how much time it is growing up in size, even though you have set it up a retention policy, to see when you will reach out to the moment that you have to pay for an extra storage.
Exactly. Always related to why database grow is the concept of blobs. So I think that a lot of your, probably at least a lot of your users use these attachments in Business Central. And if you attach in Business Central, there's a very nice feature that permits you to attach files to your documents or your entities in Business Central. And these attachments are automatically saved into the Business Central database. This can be a really big problem if your user abuses of that feature. So if you discover that your users uses attachments a lot, it's absolutely recommended to automate the redirection of this media to an external storage. And our recommendation is to use Azure Blob Storage for that. Business Central has a standard module that permits you to use the Azure Blob Storage directly from IL code. And for example, simply subscribe to 2 events in the document attachment table, the on before insert attachment, on the on after insert. You can directly provide your user experience a totally transparent experience for handling attachments. So you can upload the attachments via standard user interface, so the attachment document page. Then this attachment is automatically redirected to the blob storage, the Azure Blob Storage. So save externally, not inside the Business Central database, but into the Azure Blob Storage with all the advantages of the Azure Blob Storage. First of all, cost, but not only cost, also backups, redundancy, geo-redundancy, or something like that. And your users can then open and download the attachment as before. So this is an important approach that honestly we recommend to do on every customer on SaaS, especially if these customers abuses of attachments, or if you have features that requires handling large files or something like that. Don't save this file into the Business Central database, but not only in terms of cost of the storage, but also in terms of database optimization. It's much better to save this unstructured data to an external storage. Here is an example.
Right, yeah, of course. Right, that is correct. As you can see, this is, again, a real life scenario, 150 gigabytes. And then you might say, okay, there's no problem with this one. But as you can see, this one has the capacity that is more than double in size, 206 over the capacity. But what it is determining this, the capacity. So if you go into the table information, then you might see a classic example of what we have shown before. The first one, it is records that are storing files, PDFs or big files. You can see the number of records, it is quite small, 62,000, but the size is 38 gigabytes. This means that those are big files. The second one, it is another custom table, and this one has quite a lot of number of records, but in size it is 28 gigabytes. And this one, most probably, it is storing the body of the calls of the web services, because maybe someone would like to have a look at this one, but nobody will ever do it. That is bad. Both of them could have been and should have been outside in Azure Blob Storage, in SharePoint, for example, the documents, and even everything has to be on outside. And if you do the math, you can have saved more or less 60 gigabytes for each of this kind of environment, and right now everything will go back into the capacity.
Exactly.
Yeah.
So let's talk a bit about also best practices for developers. So mainly related to writing code. Also, writing code affect performances, especially on large customer. And when talking about that, I always say that a code that works and that works perfectly in a small customer can be a problematic code in a large customer. So it's not automatically your code should always be carefully evaluated, because if you have an extension that works perfectly in a small customer, it's not absolutely sure that this same extension works perfectly in a large customer. And if you analyze what happens in when Business Central executes IL code, you will discover that the IL statement, so no database statement, when you don't have access to the database, is around 1 millisecond. So in the terms of, in the order of milliseconds to execute an IL instruction that doesn't access to the database. But when you have an IL instruction that access the database, this can be a problem, because this spans from 1 milliseconds to also several seconds if your code is not optimized. So there's a big gap between non-database access and database access IL statements. And if you analyze what happens during the day in a Business Central NST, the service tier, you will discover that the NST spends 99% of the time waiting for a database operations. So this means that database operations, related operations, when you access the database in IL code, is crucial. And writing a fast and less locking code is crucial, especially in a large customer, so where you have high concurrency. This is where these values affects a lot your experience.
So how you can tackle this kind of problem? So the first thing that you have to do, you just have to take the right amount of data with the right isolation and with the right number, the less number as possible of SQL statement. So what we did, me and Stefano, we thought about to take a base application, and then in version 23, 24, 25, and then from this one, the value that you can see in bold, this one are new with double quotes, AL statement that might help you retrieve the data in the most efficient way. And if you don't trust even us, even myself, I don't trust sometimes, trust Microsoft, and trust Microsoft that it is implementing this one. So let's take the settled fields. Settled fields from version 23 to version 25 almost doubled in the base application. The settled fields, it is in the partial record, will help you take only the fields that are needed. This means that most probably you will cut out the join. Cutting out the join, then you just have a more skinny execution plan, and just have quite a lot of more goodies in terms of performance. The second one, it is the read isolation from 106 to 230. The read isolations, it is related on concurrency. So it is very important that you set this up in the right statement. For example, is empty, if I can say to you that if you proceed is empty with the read and commit, then you do always everything but good. Or if you proceed the read isolation with the read and committed on every calc fields or calc sums, then you might prevent unwanted locking behavior on calculated fields behind the scenes. And then last but not least, the set autocal fields. It has been growing on. The set autocal fields, it is used to quite reduce the number of SQL statements that has been sent over. And believe me, in the online, the latency that is between the NST and your databases, it is not the same as in your machine or in your Docker container in your machine. Then the last two are the read-only. Read-only, it is growing up little by little, and log table, it is something that you have to completely forget in your daily practice. Instead of log table, this one, it is something that you have completely erased as an EL statement. Instead of log table, use the right read isolation, for example, UPT log, in order to be very granular in the isolation level, in order to express the best concurrency in your development. That is the pattern that always apply. This example that you can see here with the set range, the find set, and at every time there is one record, you go into SQL Server in order to calculate the field that is called into the inventory, then this one, it is quite bad. And that's to be transformed, for example, as a general rule, with a more modern code. Well, After the set range, you define the set load fields that are the one that are needed by you. In this case, you only need one, that it is the safety stock quantity that is used in the statement nested within the if, and then the set autocal fields inventory will tell DAL to create an outer apply in the same statement where it is retrieving the data, it is also executing the calculation of the flow field, and the read isolation. This one will have always to be read and committed. This means that it will never apply any kind of locking. Yeah, exactly.
Another loop, another example is this. For example, we are imagine that you have a code, like in this example, that need to have a nested loops across very large tables. So in this example, for every item in the item table, imagine that this item table has millions of records. You need to go into the item ledger entry tables, retrieves the item ledger entry records that applies to that item, and then do some calculations. This, if the item table has millions of records and the item ledger entry has 10,000 or millions of records, this takes ages to execute, and this is very, very slow. So this is something that is a bad code, and probably you need to improve a lot in order to improve the performance of your customer, especially when these tables are big. Solution for that is using, for example, query objects. Query objects are an IL object that permits you to define queries, and queries works at the SQL level directly, no caching, and directly execute at the SQL level, and you can perform joint across tables. So here, the previous code, we transform the previous code with using a query. So the query that starts from the data item on the item table, and then performs a SQL join on the item ledger entry tables. With a single object, creating the object, the query object, then you can use the query objects in code. So the previous nested loop is now transformed in this loop. So opening the query and then looping across the query results. This is absolutely faster and faster compared to the previous code. So previous code maybe can be easy because you create a simple loop in a language, nested loops. Here you need to create a query and then use the query. But if you want to have performances, this is the way to go, because when tables are very big, this is the best way to handle performances in such type of user scenarios. And then we talk a bit, the last aspect about large customer. As Duilio mentioned before in the scenarios, one of the aspects that you need to also consider when handling a large customer is not only what happens inside the Business Central database or your AL code, data growth, data access, and something like that, but also the integrations that you have, because integrations can have an impact and usually have an impact on your Business Central tenant and your Business Central experience. When talking about the integration, we talk about API integrations. So, and API integration are normally reading data and writing data. So operation that writes and operation that reads. First of all, let's talk a bit about reads. Reads operations, recommendation is to offload to read-only replica always when possible. And this offload to the read-only replica can be done when you have an API page, can be done in two possible ways. The first way is defining the object with data access inter read-only property set to the API page or the API query page. And the second is the caller. The caller can redirect its call to a data access a read-only replica by specifying in the header of the call data access inter read-only. As we said before when talking about that, remember that the data access inter property when we set it to read-only does not guarantee absolutely that your data access will be running on the secondary replica, because it's not always guaranteed that you have the read-only replica. It depends on the service tier where your Business Central database is. So the data access inter read-only purely states that the code only requires a read-only connections to your data. So
It's
if you have
just the
read-only data
int.
available, it's directed to read-only replica, otherwise not, but it's a best practice to use data access int and read-only when you have a read-only, when you have to read data. The second aspect is writing data. When you write data, you need to perform a post operation. And when talking about post operations and you have massive writing data, recommendation is to use batches. Batches are particular APIs endpoints that respond to these endpoints, $batch, or this is the custom endpoints when you have custom APIs. Batches permits you to do multiple posting in a single call. So you can pass a JSON with the multiple operations that you want to perform or multiple reports that you want to register in Business Central in a single call. So this permits you to limit the number of calls that goes to the Business Central database. And when using batches, you can also set 2 header tags in the Business Central calls. So in the API call, the first is prefer or data continuum error header tag. If you set this on the header of the call, this means that you can avoid stopping if a record fails. So if you post 10 records or 100 records and one fails, transaction is not stopped, but you can go posting the others. Another useful tag is, in this case, the isolation snapshot header tag. And this is useful if you need transactional behavior. So if your batch must be totally rolled back or not if something fails. So these 2 headers are important to be set from the caller in order to guide the behavior of your batching operation. But batches are important if you have massive operations. But sometimes batches can not be the full solution to apply, because obviously batches means that from the external application to Business Central, you always need to be connected. And sometimes if you have massive external application that post data to Business Central, this can be always a problem. So here we want to quickly show you a real example of that. So here is a chart coming from telemetry of a real big customers, where during every moment of the day, there's a massive number of APIs requests per minute that spans from also more than 5,000 per minute. And this is a very massive number of operations that affects the performance of their tenant. And so when we discovered this problem, we start analyzing that, and telemetry was the first way to analyze that. And analyzing telemetry, we discovered that in this example, more than 70% of the access to that tenant, API access, was reading data, so GET operations. And then we have a huge amount of POST also, but the main part was GET. We decided to apply some more advanced techniques that spans also with external services. So in order to improve the performance of that tenant, we decided to decouple Business Central from the external application. And we decided to apply caching to the APIs. This means that the external application, when sending a GET request to Business Central, the GET request is intercepted by a middle layer, in this case, an Azure function, that uses caches, Redis cache in our scenarios. That is an Azure cache. So data is, first of all, checked from the cache. So I want an information about the customer card, for example. First of all, I check in the cache. The customer card is in the cache? Yes. Then the response is automatically returned to the caller without going to Business Central. And in the cache, you can also specify a timeout. So I consider valid a data for 2 minutes, 2 hours, 1 day, 1 second, and something like that. So you can, it's a parameter. So if the data is valid in the cache, it's automatically returned to the caller without going to Business Central. If the data is not in the cache or is not valid in the cache anymore, the data, the API call is routed to Business Central, and then Business Central is saved into the cache and returned to the caller. This trick, decoupling things, where is also one of the best practice when architecturing serverless application in general, permits us to moving from these scenarios, previously chart that I showed, to these scenarios. So as you can see here, it's much more slow than the API call sent to the tenant compared to this. And also the response time was quicker. So here in blue, you can see the time for response without applying these techniques. And in orange, the response time, the average response time when we applied these techniques. So we experience a much more quicker response time compared to the previous version. Obviously, as you can see in the chart, there are also some spikes again. And these are the posting, because you can cache the posting. So for posting, if you want to decouple, one of the techniques that we applied in some big customer is the following. So when I have an external application that massively posts data into Business Central every time of the day, we decouple things. So the post does not directly go to Business Central, but is intercepted by an Azure function or something like that, a middle tier, and is cached in a queue. Then it's Business Central that retrieves the data from the queue when he wants and then posts that data. This is avoids blocking, permits to have decouple of the system, permits to have an external system that can massively post every second without impacting on the Business Central and on the standard operational activities that your users are doing. So it's just a technique that we applied on real world customer. So remember the batches and this. So here this is our recommendation and our tips for handling a large customer. All the experience that we have with some of probably the biggest SaaS customers together today in Business Central. So we are free to answer some questions. If you have, feel free to write in the chat.
Yeah, I can see there are already a couple.
The chat, sorry, 1 second that I open. Okay, please, if possible, expound on caching in API integration. Okay, the techniques of caching is simple. When you have a massive operations, a massive external system that sends massive operation to Business Central, the simplest way to do is exposing Business Central APIs. But exposing Business Central API is simple, but not a generally speaking, is not a best practice on a SaaS world. When you are without not restricting this aspect to Business Central, but in general, when you create applications in the cloud, it's always better to decouple applications. So two applications must be independent. And so here, what we have done, we have in this scenario where we don't want direct connection between an external application and Business Central because the impact is big. We create a middle layer in the middle, and this middle layer is in our scenario is simple and Azure function. What this Azure function is doing is easy. It simply receives the API call. So you have an endpoint. Instead of calling api.businesscentral.dynamics.com, you call your Azure function something. This Azure function retrieves the API calls with the body or the filters. And then the Azure function uses the caching. The caching in our case was Azure Redis Cache. That is a service available in Azure for caching data. So the first call goes into the cache. I imagine that I want to retrieve information about customer Cronus. Okay, I send an API call get customer Cronus. Data is in the cache? No. If no, the API call is then routed from the Azure function to Business Central, and it's the Azure function that performs the real API call. So Azure function performs the API call, retrieves the Kronos customer data, saves the data into the cache, and then returns the data to the caller. So the caller simply calls for information about Kronos, receive data about Kronos. The second time that a new caller give me the information about customer Kronos, the Azure function intercept that and checks Kronos is in the cache. Yes, because someone before has called about Kronos. So it is immediately goes the response to the caller, and this is fast, nanoseconds compared to some probably seconds that it requires to perform a Business Central API. So extremely fast, and this second call does not go into Business Central, so you avoid that these sequential calls goes impact to the Business Central database.
And when you validate the cache, Stefano?
The cache must be validated. When you set the data into the cache, you can specify the timeout of the data from the cache. So when you retrieve the customer and save the customer data into the cache, with saving the data into the cache, you can specify the timeout. So this data for me is valid for, I don't know, 2 minutes, something like that, 3 minutes, 1 hour. It's absolutely up to you. This means that when I save the data into the cache, this data is marked by the Azure cache as valid until the timeouts is disappear. When the timeout is disappear, the data is not valid, so it's expired from the cache. So if I save that Kronos is valid for 2 minutes, and I call that a new API request to retrieve the Kronos data after 5 minutes, the data is not again in the cache. So a new API call to Business Central is performed in order to retrieve the latest data. So the drawback of the cache is that you need to consider the data valid until a delay, a timeout of period. That is totally up to you, but it's automatically validated by the Azure Redis cache, simply applying that the timeout. Cache impact writes operation in any way, and how do you synchronize changes between Redis and Business Central? How do you synchronize is what I've just explained. So the Azure function routes the call to Business Central and then saves the data into the cache. Just to show you the few, I don't have here in this PPT, but it's very one lines of code that simply when you have the data is going to Business Central is then saved into the cache. Write operations are usually something that has no impact on the cache, because when an external application wants to write an operation in Business Central, cache is not impacted. So write operations needs to go into the Business Central database if you want to save the data into Business Central. So for write operations, or you directly call the post of the Business Central APIs, or as we suggested, if you have massive write operation that where you observe an impact of write operations, what you can do is something like very similar to what Duilio described before for the internal posting. So serialize means that your external application can save the data into, for example, a queue, and then his Business Central then can parse that queue and post the data. So I can have an external application and can post 1,000 of records every second, but in Business Central I queue all these records, and then it's Business Central that writes this record when he wants and with the timeline that he wants. That's the trick.
Yeah, it is shielding. It is shielding the endpoint from a massive number of calls. That of course will reduce the performance. So that is a smart way to do reads and also writes. Reads the first example and writes the second one.
Exactly.
Yeah.
If you have other questions, otherwise. No more questions?
Hello.
Hello?
Stefano.
Hello?
The gentlemen, thank you so much. Joyce, kindly take on.
Thank you. Thank you, Stefano. Thank you, Giulio. And as we come to the end of this insightful session, I want to take a moment to thank our speakers for sharing such deep expertise on best practices for Business Central Cloud. And I feel like the knowledge imparted today, particularly on optimizing Business Central with Redis caching, has incredibly been valuable and even thought-provoking. We truly appreciate your time and effort. A big thank you to everyone who attended, engaged, and contributed to this discussion. Let's take these learnings and apply to our projects. Once again, thank you, Stefano. Yeah. Thank you, Giulio. And we look forward to more such sessions in future. And wishing everyone a great rest of the day.
You too.
Thank you.
Thank you very much. Have a nice day. And feel free to, if you have more questions later, feel free to reach me and Giulio on our channels.
Thank you. Thank you so much. Bye.
Bye. Thank you so much. Bye, everyone.
Bye-bye.
Bye. Bye, everyone.